We're going to be working on 2.4, multiplying rational numbers today. The first section that I want to talk to you about is this says, without multiplying, tell whether the value of the expression is positive or negative, and then explain your reasoning. On your 2.4 homework, there's going to be a couple questions that are exactly like this. I am not asking you to give me the answer. I'm simply asking you to tell me, is the answer going to be positive or negative? If you look at this, we have a rule that we've talked about. It's the even and odd rule. If you have an even number of negative signs, your answer will always be positive. If you have an odd number of negative signs, your answer will always be negative. So let's look at the first one. -4 times -2. Should my answer be positive or negative? It's going to be a positive one. Now it asks us to explain our reasoning. Can anyone explain to me why it is that this answer is going to be positive? Okay, there's an even amount of negative signs. So if I count there, I can see there are 2 negative signs, which is an even number. So because there's an even amount of negative signs, my answer has to be positive. Looking at the next one, we haven't multiplied positive and negative fractions together yet, but the rules still apply. How many negative signs do you see there? There's only 1. So guys, is my answer going to be positive or negative? It is going to be negative. Can someone explain your reasoning? Why is my answer going to be negative? Keaton.
If there's an odd amount of negative signs, your answer will be negative.
You are correct. There's an odd amount of negative signs. All right, so anytime that we have an odd amount of negative signs, our answer will always be negative. All right, for the next section, there's 3 ideas that I really want you to know and understand that we need to know whenever we're multiplying fractions. Go ahead and pull out your red pens, and please fill in the next 6 blanks. All right, these are really important rules that we're going to want to know. So if you would, just go ahead and take your red pen, and I want you to draw a cloud around this section to help you to know. Go back to here if you are looking for rules about section 2.4. Let's read what the first star tells us. Go ahead. You do not need to find a common denominator when multiplying or dividing fractions. All right, so that makes me really happy. When you add and subtract, you have to have a common denominator. But when we're multiplying, we don't. We just get to multiply it right across, okay? Read me the next section in blue. What's it say? You cannot multiply mixed numbers. You must make them improper first. That's a rule you're going to want to remember. And read me the last thing that we're talking about today. If it starts as a mixed number, the final answer must be a mixed number. Meaning, it's got to be a fraction. It cannot be an improper fraction. It must be a proper fraction or put back into a mixed number. So let's go ahead and do some examples. Find the product. Just remember, anytime it says product, am I going to be adding, subtracting, multiplying, or dividing? Factor, factor, product. What would that be? It is multiplying, okay? So we are multiplying these ones, and write the fractions in simplest forms. That means simply have to reduce it, okay? So we're going to go ahead. Do I need to find a common denominator, yes or no?
Yes.
Everybody, go back to your big red fluffy cloud that we just did and read me the first star. What does it say?
You do not need to find a denominator when multiplying or dividing fractions.
So let me ask you again. Do you need to find a common denominator?
No.
No, you do not. Instead, we're just going to multiply the numerators together. Guys, what's 1 times 3? 3. To the right, I want you to go and put a 3. Let's do the denominator. What is 5 times 8?
40.
40. Can 3/40ths be reduced?
Yes. No.
No, there is nothing that goes into a 3 that also goes into a 40. So the correct answer is 3/40ths. That's it. Let's go over here to the right-hand side. What do I have to do first?
We have to
Let's make that mixed number an improper fraction, because remember, we are not allowed to multiply mixed numbers. So repeat after me. Drop it down. I'm going to drop down the -1/3. What would this next thing be as an improper fraction, class?
11/4.
Okay, not just 11/4. If it was There you go. Since there was a negative there, I've got to drop that negative down, and the answer is negative 11/4. Now, on your own, I want you to go ahead, multiply across the numerators, and then multiply across the denominators. What'd you get, guys?
11.
Okay, 1 times 11 is 11. And then you take the denominators, 3 times 4 is 12. Can that be reduced? No, it cannot. Now, I had a negative multiplied by a negative. What should my answer be, positive or negative?
Positive.
Positive, because whenever I have two negative numbers, that's an even amount of negative numbers, my answer is going to be positive. And 11/12 is the correct answer. Next, we're not going to be working with fractions. Instead, we are working with what? Decimals, okay? So this is also a rational number because it's a decimal. Let's look and just figure out, is my answer going to be positive or negative, class? Negative. How can you tell it's going to be a negative? There's only one negative number, okay? So if it helps you, off to the side, you guys can go ahead and put a little box and put the negative inside so that you know for sure when I rewrite my answer, I'm going to get a negative. You don't have to do that, but you can if that's helpful to you. Now, just as a reminder, when you are multiplying decimals, you do not need to line up the decimals. In this case, they are going to line up anyway, but you do not need to line up the decimals. Now, every number has a decimal point over here, but this one has been moved over. How many times did that move over to the left? Only one time. I want you to take your little red pen and put a 1 right there because it says I moved the decimal point 1 time over to the left. This one started here. It got moved over. How many times? Only 1 time. Take your red pen and put a little 1. Now I want you to take an arrow. Guys, add those together. What's 1 plus 1? 2. This is saying with your final answer, you have to move the decimal point over 2 times. 5 times 6?
30.
Okay, 0 on bottom, 3 on top. 2 times 6?
12.
Plus 3?
15.
Very good. Okay, now I'm crossing this out because I don't need it anymore. I'm done with the 6, and I'm just going to be multiplying that 2.5 times the 3. What do I put as a placeholder, class? 0. Go ahead, keep going, Keaton.
3 times 5 is 15. And you carry the 1 on top of the 2. And then 3 times 2 is 5 plus 1.
No, 3 times 2 is
6.
6 plus 1?
7.
7. Then let's go ahead and add this together. What do you get?
You get 900.
Okay, 900. Now, if you remember up here, we came up with this little number 2. That tells me that the decimal point right now looks like it's here at the end, but I need to move it 2 places over. If I do that, what's my answer?
9.00.
9.00. And do I need those zeros at the end after the decimal point? No, so what's my answer? 9. Now, if you remember, I already put the negative over here on my final answer, but if I go back here, I can see I had 1 negative number times 1 positive number, so my answer needs to be negative. So the final answer is? Negative 9 is correct. Now, once again, I want you to always make sure you're rewriting that answer. I don't want you coming over here and boxing this in because it's just a bunch of work. It's kind of messy, so we're just going to rewrite it off to the side. Let's do another example. Starting off here, is my answer going to be positive or negative for problem D? Positive. How can you tell that? Okay, if you want to put a little plus sign there, you can. You don't have to. You can decide that at the end. Let's go off to the side and go ahead and put our numbers over here. Do I need to line up the decimal points? No. When we are multiplying, we do not line up decimal points. But I do want us to figure out how many places over the decimal point has moved. How many places has it moved to the left on point 51? 2 places. Everybody put a tiny 2. How about this one, 1.8? How many places did that decimal point move? 1. Add these 2 numbers together. What's 2 plus 1? 3. That means we will be moving the decimal point 3 places at the end of this multiplication problem. Help me out with this, please, Vivian. 1 times 8? 5 times 8? Very good. Now I'm done with this number. I'm going to put 0 as a placeholder. Keep going.
1 times 1 is 1, and 5 times 1 is 5.
Very good. When you add these together, what do you get? Very good, 918. Now, how many places did I tell you up here we needed to move our decimal point? 3, very good. So we know it starts all the way on the right side, but it's moving over 1, 2, 3. What is our final answer? 0.918. Now, we talked about this the other day. What place is that 0.918 in, class? Not the hundreds and not the tenths, the thousandths. So what would this be if I said it the proper way? 918 thousandths. Very good. Do I need to keep that positive right there in the box? No. So I can go ahead and get rid of it, but just remind yourself it was 2 negatives multiplied together, so my answer has to be positive. For section number 3, it says, use number properties or shortcuts to multiply. Does anybody remember that shortcut or that number property I taught you that says you're allowed to move numbers from one place to another and it won't change your answer? What was that? What did you say? Who said it? Commutative. Great job. Go grab a candy for me, please. The commutative property says you can move a number around and it's not going to change your answer. Now, before we move on, I do want to show you guys one thing. If I look up here, most of these are fractions, but one of them is a whole number. What does the whole number say, class? -7. What can that -7 be? I need to turn it into a fraction. What would it be? -7/1. I'd like everybody to go and do that for me, please. Now, there's not a ton of room at the bottom here, so instead I want you to make sure you're writing kind of small, all right? Please do not write this down, but I do want to go over one idea with you beforehand. So go ahead and put your pencils down for me, please. Today I want to teach you something called reciprocal. And we're going to talk about this later on in a different lesson, but I want to make sure you understand it for right now. If I were to have 5/6, if I were to flip it, the reciprocal would be 6/5. As you can see, all I did was I switched the numerator and the denominator. Let's say I had another one, 2/3. What would the reciprocal be? 3/2, 3/2. All I'm doing is switching it around. Let's say 4/9. What would the reciprocal be? 9/4. Excellent. Okay, let's go on to another one now. A different idea. Let's imagine that I am now going to cross reduce. How many of you guys remember cross reducing? Okay, so let's imagine I have something that says maybe 2/8 multiplied times 4/12. If you remember, cross reduce means you can find a number. What's a number that can go into a 2 that also goes into a 12? Not a 6. A 2. How many times does 2 go into 2? 1 time. How many times does 2 go into 12? 6 times. Now let's focus on this one. What's the biggest number that goes into 4 and 8?
4.
A 4. How many times does a 4 go into a 4? 1 time. How about into an 8? A 2. So remember, this is the idea of cross reducing, and we will be using that here in just a minute. Now, back to the commutative property idea, okay? We want to find the reciprocal up here. In my example, there's 4 fractions, but 2 of them are reciprocals of each other. Who can find the reciprocals for me in problem A? Remember, a reciprocal just means it's been flipped. Jonathan.
1/7 and 7/1.
You are correct. This one and this one, they are reciprocals of each other. So repeat after me, commutative. The commutative property can tell me, hey, if you want to switch the order of those, you're allowed to, okay? Those guys right there, they're reciprocals. They are friends. They want to be next to each other. So I'm going to allow them to move around. Let's drop down -1/7. Once again, please do not write big. I want you to print about the size of the ones that I have printed on your paper in your notes. I am moving now, parentheses, -7/1. What's another fraction that I still have to bring down from my original problem?
5/4.
Not 5/4. 4/5. I am multiplying. I would like to get rid of that tiny little dot, so I'm going to be putting my parentheses. There's still another one I have to multiply together. What is it?
-1/2.
Thank you for saying negative, because every number has a sign, and that sign is directly in front of that number. Excellent. I want us to focus on this first section right here. Is there anything I can cross-reduce?
7.
The 7s. What are both of those 7s going to become? They're going to become ones because a 7 goes into this one time. It goes into this. There was a negative there, so I'm going to keep that negative, all right? Now let's focus on this. I am multiplying in that yellow circle a negative times a negative. Is my answer going to be positive or negative if I'm multiplying two negatives together?
Positive.
It'll be a positive. Now, what would 1 over 1 times 1 over 1 be?
1.
Just plain old 1, and it's going to be a positive 1. So that right there turns into a 1. Instead of all this big mess, it simply means multiply it by 1. Now, what do you think I need to do with the rest of this over here? Drop it down, okay? So we can underline it if we want, that's fine. Bring down 4/5. And remember, whenever numbers are right next to each other with parentheses there, that means I am multiplying them together. Looking at all of this right now, how many negatives do you see? 1 negative. So is my answer going to be positive or negative? It will be negative. To the side, I'd like you to write equals. It's going to be negative. Now I want you guys to multiply the numerators together and then multiply the denominators together on your own. Ethan, what did you get when you did that? Okay, so we already know it was a negative, -4/10. Vivian, is that reduced as simply as it can be? No. What can go into a 4 that can also go into a 10? A 2. When you reduce it, what do you get? 2/5. And Vivian, is my answer positive or negative? It is going to be a negative. So the correct answer is -2/5. Now, if I were to go back up here to my original problem and I was to count, I can see 1 negative, 2 negatives, 3 negatives. That's an odd number, which means my answer should have come out a negative. Very good, and it did, right? Let's move on to the next one. Does anybody see a reciprocal there on problem B? Taylor, what is it? All right, so you do see there -2/3 and 3/2. We're going to use the commutative property that says I can switch them around. So let's drop down the first one, -2/3. And now all I'm doing is I am switching the order of these two. And remember, when I switch the order, when I'm multiplying, I'm still going to get the same answer. So now I'm going to multiply times 3/2. And I still have to bring something else down. What am I bringing down? 7 and 7/8. Now remember, I'd like to replace it, and let's put some parentheses there. 7 and 7/8. That means I'm multiplying. I want to focus on this first one right here. Is there anything that can cross-reduce? Everything can. What do the 3's turn into?
1.
They're going to turn into 1s. What does the -2 and the 2 turn into? 1s. Okay, -1 is still going to be there, and this will be a 1. I am multiplying a negative times a positive. What's my answer going to be? Negative, and 1 over 1 times 1 over 1 is simply 1. -1. What else do I still have to bring down? Thank you for saying times 7 and 7/8. Let's focus on the sign. Should my answer here be a positive or a negative? It's going to be a negative because there's only one negative. Now, what is 1 times 7 and 7/8? 7 and 7/8. Anything multiplied by the number 1 will always equal itself. So your correct answer is -7 and 7/8. Final problem of the day is a modeling real life. A school record for the 40-meter dash is 15.24 seconds. Predict the school record after 15 years when the school record decreases by 0.06 seconds per year. So right now we have someone who, let's say, is anybody in here interested in track and field? You're a good runner. Okay, Sequest, we're going to use you as an example. So let's imagine Sequest has set a record. Right now, he's able to do the 40-meter dash in 15.24 seconds. That's awesome. That's the school record. He's beat everybody in the past. But here's what it says. We are trying to predict or guess, okay? We're trying to guess in a smart way what the record is going to be in 15 years. So let's imagine that Sequest has a kid, and his kid comes to Trinity in 15 years. And that kid is really fast. And here's what this problem tells us. The school record decreases by 0.06 seconds per year. So the first year, it goes down 0.0 seconds. The second year, down 0.0 seconds again. Down the next year, 0.0 seconds again. So you can imagine it's getting shorter and shorter and shorter, which means Sequest Kid is even faster than he was. So what we have to do is figure out, what is Sequest Kid in 15 years? What do we guess his time will probably be? And there's a smart way that we can figure this out. We have to start by right now what Sequest's record is, okay? So we're going to go ahead and write this down. The current school record. After that, I've got to add something. Can you guys tell me what you think? What else might I need to do to try to figure out what Sequest's Kid's record will be in 15 years? The number of years that we're talking about in the future. So I'm going to use a different color. I'll use my green. We're going to use the number of years. Now, I've got to multiply the number of years by something. Does anyone think you might know what I'm going to be multiplying the number of years by?
15.
Jonathan? Correct. The seconds per year. I want to talk about this per year. Anytime you see that word per something, it's always going to be multiplying. So we've got to multiply times the yearly change. How many seconds it was changing every single year. So once again, I have put my parentheses because this is multiplying it by how much it changes each year. If I look at this, we know that it's changing 0.06 seconds each year. I could add up together 0.06 plus 0.06 plus 0.06 plus 0.06. I could do that a whole bunch of times, but there's a faster way, multiplying it together. And that's why that word right here, per year, helps us to know we're going to multiply that. So now we're doing some substitutions. Repeat after me. Plug it in, plug it in. Let's start right here with the current school record. What is the current school record, class? 15.24. I'm plugging it in. What should I do with my plus sign? Drop it down. What is the number of years? How many years away are we going to test Sequest's son's record? 15. And I have to multiply that by the yearly change. How much is it changing each year, class? 0.06. Now here's the deal. It says it decreases. Is that going to be a positive or a negative integer? A negative. So by negative 0.06. Underline this part right here. According to PEMDAS, I've got to do my multiply before I do my adding. Now remember, I could add negative 0.06 plus negative 0.06 plus negative 0.06. How many times could I do that? I could do it 15 times because it's 15 years, but it's just easier to multiply it instead of adding 15 different times. So off to the side, I want you to multiply 15 times 0.06. Do I need to line up my decimal points?
Yes.
No, when you multiply, you do not have to. But you do have to count how many times the decimal point moved over. How many times did that decimal point move over in the number 15?
2.
0 times. It's over here at the end. You can't even see it. It hasn't moved, so 0 times. How about this one, 0.06?
2.
That one's moved 2 times. Add those two together. What's 0 plus 2?
2.
So I am going to be moving my answer 2 places to the left. I want you guys to multiply that together on your own. This kind of a question will be on your quiz next week on Monday, and it will be on your test next week, which means I really need you to make sure that you are writing down the notes exactly like I have it here. Guys, when you multiplied that together, what did you get? Not just 90. How many times do I have to move that decimal point over? Okay, move it to the left 2 times, you get 0.90. I'm going to go ahead and put this down here. I was multiplying a positive times a negative, so my answer is going to be negative 0.90. What should I do with this part of my problem? Drop it down. 15.24 plus a negative. I have 2 signs side by side. Who always wins?
Negative.
The negative. When I am adding a negative number, that means I have to minus. So I can get rid of this right here. And now I'm going to subtract 15.24 minus 0.90. Do I need to line up my decimal points? Yes, you do. Every time you add or subtract, you have to line up your decimal points. So over here, I want you guys to go ahead and subtract it for me and find your answer. All right, guys, as I saw and I walked around, I saw a lot of 14.34s and I saw some negative 14.34. What should it be, positive or negative?
Positive.
It should be positive because same sign, add and keep, different signs, subtract, and take the sign of the larger number. The larger number was a positive, so you do not need to put a negative. All right, guys, this is a modeling real life problem. One thing I saw everybody forgot to write was the units. What is the answer? 14.34.
Per year.
Not seconds per year. This is what it says. Predict the school record. The school record is not going to be 14.34 seconds per year. We already know it was 0.0 seconds per year. So the final answer should simply be, I'm predicting the school record is going to be 14.34 seconds. So when Sequest's kid comes along and he does this new excellent record, we are predicting he'll be down to 14.34 seconds. Once again, please go back, rewatch this kind of a problem. It's going to be on your quiz and your test next week, okay? You're going to have to start with whatever the current thing is and then add the number of years and multiply it by the change. So tonight, you do not have to accomplish this homework, but 2.4, you are going to have how many problems, class?
9.
There are only 9 homework problems tonight. If you want to get started on the homework tonight, you may. If not, we will work on it in class. So you may work it on in class with us. But tonight, your homework is to begin working on your timeline events for your project.